Okay, question 9 part 2 wants us to work out the stationary coordinates and also decide what type of stationary point we've got by considering either side of the stationary point. So if we have a situation where on the left hand side of the stationary point we have a positive gradient and on the right hand side we've got a negative gradient, that would tell us we've got a minimum point. If it was the other way around, it would tell us we've got a maximum point. We might also have this situation here called a point of inflection, where it goes positive 0 and then positive again, or this situation here where it goes negative 0 and negative again. But we won't know until we've actually tested either side of the stationary point. So let's find the stationary point first. So that's going to be when dy by dx equals 0. So 2 over t minus 2t squared needs to equal 0. If I times everything by t to get rid of the fraction, that will give me 2 minus 2t cubed equals 0. Move the 2t cubed to the other side. Divide by 2, sorry. Cube root. So that tells me t equals 1. T equals 1, but what are x and y? So we need to go back and substitute 1 into here, and here, and here. So when t equals 1, x equals 1 over 1 minus 1, which is 0, and y equals 2 times 1, which is 2, plus 1 over 1 squared, which comes out at 3. So the stationary point is at 0, 3. That's for x and for y. So we now need to think about, we need to look at a coordinate either side of this stationary point. So it's usually good to keep close to the x coordinate. So I'm going to look at when x is minus 0.1 and when x is positive 0.1. I do need to work out what t values that relates to so I can substitute it into the gradient function. So x was 1 over t minus 1. So when x equals negative 0.1, that's going to give me 0.9 equals 1 over t. So t is going to equal 1 over 0.9, which is the same as 10 over 9. And when x equals positive 0.1, that's going to give me 1.1. T will be 1 over 1.1. You'll see that in a second. If I add that 1 over, I'll get 1.1 here. And so t is 1 over 1.1, or 10 over 11. So at x equals negative 0.1, in other words when t equals 10/9, the gradient, which we wrote down, was 2 over t minus 2t squared, is going to equal 2 over 10/9 minus 2 times 10/9 squared, which is the same as 18 over 10, so 1.8, or you can just type it all in on your calculator. That comes out negative, minus 0.67. At x equals positive 0.1, which was when dy by dx was 10/11ths, we get a positive number, 0.55. So what that tells us is that on the left hand side of the stationary point, so stationary point's here, on the left hand side we know the gradient is negative, and on the right hand side, so we know it goes negative, then 0, then positive. So that tells us it's going to look like this, which means it's a minimum point.